Hi there, Tayyip. It's Matt Edwards here.
Hi, Matthew. How are you?
Yes, not too bad. How are you? Where are you calling me from?
From Paris.
From Paris.
Yeah.
How are things there? We had snow this morning in London.
We have a summer day today.
Lucky you. So I think we have, I'm just going to check. I think we have one other person joining us for this next session. Yeah, Ranganai. So we'll see. Do you have some slides prepared for this session, Tayyip?
Yes.
Would you mind just sharing those now so we can check that it's all working?
Maybe my colleague Ranganai will share the slide.
Okay, yeah, that's no problem. Let's see. I'll wait for Ranganai to turn up.
Hi, Ranganai.
Ranganai. Just waiting for your audio to connect. There we go. Hello.
Yes, hello.
How are you?
Can you hear me?
Yes.
Hello.
Yeah, we have
Good afternoon. Ranganai speaking. Good afternoon.
Nice speaking with you.
We need to. Nice to talk to you, Matthew. Do we need to use video, or I can just switch it off? Because
video can be off if you like. It's no bother as long as we can hear you. Do you have the slides ready for the session?
Yes.
So you should be able to use the share screen to share those. We'll just appreciate if we could just test that out.
All right, let me try. I hope that for Tayyip you already tested.
Not yet. Yeah, it's okay now. That's okay.
So, did you test Tayyip?
No, you display the slide, and because you have the large part to present.
So Tayyip,
are you going to?
Yeah. So let me try. So Tayyip, would you like Ranganai to present all the slides, the whole thing? Run the slides for you?
Yes.
Is that okay, Ranganai?
No. It's not correct what Tayyip is saying. The point is that Tayyip is going to present what Matthew are asking is whether Tayyip would display these slides. This is what you are asking, and it's not just one person presenting. Tayyip is going to present the first part of these slides.
Yeah.
And then I will take over on what we call part 2 inside the slide deck.
Excellent.
That's what we are saying.
Makes sense.
And I will take care of displaying the slides. So that's what I wanted to say.
Okay, thanks, guys. That makes sense, and that'll be it's easier to keep it with one person.
Yeah.
Good. Right, then we are ready, and so we'll be about 5 minutes, and I'll give you a nod when we're ready to go live. So it's sort of 5 minutes.
That's good.
Have you guys been enjoying the event so far? It's quite a busy day. Lots going on.
Busy day.
Yeah, myself, I've not been able to join actually because it's been a lot of work. I've been doing also projects, so I'm just joining now. So I was not able to join earlier. So
you can catch lots of it on the video on demand afterwards as well. So if there's certain sessions that you particularly wanted to catch up on, you can go on the
that's good.
On demand and catch up. Yeah,
that's good. But how has it been so far?
Yeah, I think it's been pretty good. I mean, it's like you say, Tayyip, it's a very busy day. There's just lots happening in the space, lots of things to discuss in terms of standards and how things are changing. So, yeah, had some good in-depth discussions. And yeah, I'm hoping that people are sort of on the platform networking as well. You know, we've got this swap card platform that enables sort of video calls and sort of interaction. So, I hope people are speaking to one another as well, like at a real event.
Okay. Okay, but with respect to questions, I mean, since because myself, I was not able to log into this platform. I don't know if it's because of my Vodafone laptop, because it says it's not allowing me to actually access. There's something it is saying graphical error or something like that. So I was wondering whether it means that for the questions you'll be able to, let's say, read them out, or let's say share them with us, and then myself and Tayeb will be able to let's say to respond to those questions even post.
Yeah,
post,
yeah.
event.
So I guess at about 4 your time, I can have a look and see what questions have come in and pass any over towards the end of the session. What I've encouraged on other sessions is, if there are any questions, just to message directly or get in contact. But yeah, if there's any questions that come through, I'll pass those over either in text, or I can just read them out.
Okay.
Depending what's easier.
Yeah, that's good. Thanks, Matthew.
No problem. I'll set myself a reminder to check that about 10 minutes from the end or so, and then I'll see where we are. It looks like you've got enough slides to keep us busy for some time. So
yeah, absolutely, we do. We'll share the slides after, let's say, after.
Yeah, exactly. So people can digest it afterwards. It's always very helpful when people do that. So yeah, very good. Would you be able to go full screen, Manganai, just to make sure it's as easy as possible to read that?
I don't know, full screen. Let me see how to do full screen.
Is it F5?
This one, I think.
From my side, I see full screen.
Okay. Let me see if I click.
Unfortunately, I say unfortunately, you're
no.
It's in French, so I'm unable to help decipher that.
But is it?
That's not French.
I think it's okay. Let me see if.
Yeah, no, it's still more or less readable. It's just I know you can get it slightly larger. I think it's the 1, 2, 3. I think it's the 4th icon from the right.
See if I click this one.
Yeah.
Yeah, this is full screen now.
Yeah, so that's just slightly.
Because now it's full screen. Yeah.
Great.
Now I have full screen completely. So let's see what I think.
Great. So we've got a minute to go till we go live. And all I'll do is I'll just let you know when it's time to start and hand over.
Do we introduce ourselves, or do you introduce us, or there are no for introduction for this?
I'll allow you to introduce yourselves, just so we can sort of jump straight in and move on. I'm here sort of in the background, just in case there's anything technical that goes wrong that I need to jump on. So I don't want to be involved.
Okay.
So 30 minutes. Sorry, 30 seconds to go. Okay, you can begin your presentation now.
Okay, thank you, Matthew. I hand over to Tayeb, my colleague, to start with the introduction.
Thank you, Matthew. My name is Tayeb Manmana from Orange. I am Senior Strategy Manager, and also I am TCINT EFI Working Chairman and also Vice Chair of TCINT. With my colleague, Ragana Shapraza, we have to go through this autonomic and autonomous networking multi-layer autonomics, that is ETSI GANA Framework and Federate Knowledge Plane. And we have also a testing part associated with this framework. Next slide, please.
Okay, thank you, Tayeb.
This is the agenda of presentation. In a nutshell, we started with GANA, where we come from, our history. This framework has been specified 10 years ago. We created in 2009 in ETSI, dedicated group for this work. And then we moved to our methodology and the scope. Then we go to GANA Framework itself and knowledge plane concept. After that, we say some word about stability of control loop and coordination of control loop. That's a major topic. And from GANA Framework, we have designing this framework from the outset, meaning that per design, we have this coordination and the stability of control loops. And then we have some word about testing, and we have dedicated call that came after our talk on testing framework for autonomous network. And we have proof of concept program that facilitates operationalizing this GANA framework in order to prepare operation ready and commercial ready of this GANA framework. Next slide, please. GANA stands for Generic Autonomic Networking Architecture. It is a holistic and unified framework for autonomic management control concept. In fact, we looked around and it fuses, in fact, together the well-established model for autonomic management control, such as OODA framework, IBM MAPI, that's created in 2001, or FOCAL, and a large number of European funded projects, such as FIPSANS, that was the large European project. We have also SelfNet, we have Socrates, we have eCube, we have Forward, and other research projects. And from US side, we have NSF funded project. The most of them are a clean state and 4D architecture. And also we collected other inputs from the ecosystem. That is GANA, the way that we have in GANA. Next slide, please. Regarding our methodology, in fact, in 2009, when we started this work, we created first, at left-hand side, the work item 1, dealing with scenario, use cases, and requirements that are of high interest for a service provider, for operator. That was mainly work item led by operator. And then we created another work item number 2 for model the framework itself, GANA framework itself. And then based on that, we create work item number 3, that's in the middle, for instantiation of the framework into various existing architecture and also for future architecture. In fact, GANA framework G stands for generic. That means this framework is agnostic to any implementation, to any existing architecture of its architecture. This is why there is clear separation between this abstract model, this generic model, from existing or from instantiation in existing framework or network. And we did, in fact, instantiation onto 3GPP architecture and also for NGMN architecture and also for sensor network and others. And at the right-hand side, you can see these green boxes that, in a nutshell, it summarizes what we named in our framework GANA support system, meaning that once we have defined these requirement, use cases, and scenarios, and this framework, we need to provide guidance for implementations. For instance, we have created this proof of concept program 5 years ago, and now we are demonstrated 5 use cases with our partners, meaning that we are demonstrating that we have operationalizing this framework, this standard, into products, into commercial products and solutions from our suppliers. And then we have this trust and confidence that's very important before moving toward operation, toward production network. We have to make sure that we build trust and confidence on this autonomic network because its behavior is not deterministic. where there are many things that we have not control when move from design to operation. So this is why we need to make sure that trust and confidence is built, and from some applications that are of high risk, we need also to make sure who is accountable, who is responsible. So that means we have to look at explainability of this AI model when something wrong happens. And then we have this testing autonomic software for networks. That is very important work item, and we have dedicated slot after this talk dedicated to this testing. That's very important. And once again, before moving or declaring that GANA Framework is operationally ready, is commercially ready, we need to test and certify, and then we engage other stakeholders in this GANA support system, independent tester, independent certifier that can provide testing, certification as service. Next slide, please. Yeah, we have this, our requirements framework. In left-hand side is that what has been defined in our specific technical specification. On the right-hand side, we try to provide simplified view of this framework. In fact, it is multi-layer model. On the top, we have a requirement layer that is broken down in 4 categories of requirement. We have a requirement dealing with strategy and business. We have a requirement dealing with operations, and we have a requirement dealing with governance. And finally, we have a requirement dealing with autonomic related aspect. All these requirements can be defined as design appropriate or intent that can be injected by human operator via governance interface into those layers. And the first layer that we can see that is interface with the requirement, it's a cognitive business layer, and it is controlled by horizontal closed control loop, and then down to cognitive service assurance in order to ensure service in cognitive manner, thanks to this closed control loop at the service layer. And then we look at the resources. Then we have this network layer that's a factory that allow us to use resources that facing customer service thanks to this control loop. And at the right-hand side, you can see knowledge plan that is outer loop that is outside this multi-layer model, and that policy control all these 3 layers. So that is in a nutshell our requirements framework. Now I hand over to Ranganai to present the GANA Framework itself.
Thank you, Tayyab. It's a pleasure to present the GANA Framework itself. I'll try to be very fast because of the time. So I'm working as consultant supporting the industry, the operators and vendors with respect to the space of autonomics, 5G, and moving in the direction of what we call knowledge plane driven networking, the autonomics that drives the networks of the future as we move into the future. So GANA Framework, Generic Autonomic Networking Architecture Framework. What we looked at, as Tayyab said, is that we're looking at, we fuse the different models on autonomic management and control. Some models were focusing on what we call centralized control loops. Some models focusing on distributed control loops. The question of intelligence within network elements, what the research is called in-network self-management. So we have done a lot of work in looking at the research space and validation with the implementations on the intelligence that can be introduced within the network elements, which constitute what we call fast control loops, enabling the network elements, the router, the switch, to react fast. Instead of waiting for the outer knowledge plane to actually then take some actions. So how to combine slow control loops in terms of time scaling, which have more broader scope of the whole network, as slow control loops that are fine tuning and policy controlling the fast control loops within the network elements, is what GANA is prescribing based on the principles that we have captured from best practices, best models to combine and create a holistic model for autonomic management and control. So within the network elements, we see at the bottom, these are what we call the resource layer, where we see protocol stacks, as well as various mechanisms that are inbuilt within the network element. And what we're answering here, what the GANA is answering is, what sort of overlay abstraction where we can at which to introduce decision elements. Decision elements are the autonomic software logics that implement and drive a control group of managed entities. So at the bottom of within the network element, we've managed entities, we create abstraction on top of the resource layer, and we define very specific autonomic functions. For example, quality of service management, DE, mobility management, DE, monitoring management, DE, and within the network element, the highest level is what we call the node main decision engine that is then policy controlling the raw level DEs. So that is about the autonomics within the network element. And of course, certain algorithms can be implemented as distributed algorithms, implementing distributed control loops horizontally across the network within the scope of in-network self-management at border relationships within the infrastructure. And then coming on top of that is the overlay knowledge plane as a platform that has decision elements that operate with a slow time scale within a slow time scaling, and they policy control the raw level decision elements. So for example, quality of service within the knowledge plane is policy controlling the QSDE within specific network elements that provide for quality of service function. If we look at cognition, AI algorithms, what we see within the GANA is that the complexity of AI algorithms, which are enablers for autonomics for the DEs, the complexity should increase from within the network element, because within the network element, we expect to have very simple and non-complex AI algorithms going into the knowledge plane, which is actually the host of the complex AI algorithms and cognition of the network. So that's the big picture of what we call the GANA knowledge plane. Standard ETSI TS 1031952. We started as an industry specification group, but now AFI is real standardization. It's not pre-standardization. So it's different from the ISG concept. So we moved into what we call normal standards track. So this is a standard, it's not pre-standardization. And so this is the GANA standard. So functional architecture is also described inside the specification, our standard. The holistic nature of the GANA framework is that it gives the flexibility to the implementers to make a choice on how to implement certain type of algorithms, either as distributed intelligence algorithms within network elements, or what we call then micro-autonomics, micro-control loops, which are implementing faster control loops, or to implement certain algorithms in as centralized algorithms within what we call the knowledge plane, the GANA knowledge plane, what we call macro-autonomics, and how to interwork the two levels of autonomics, policy control, the upper policy controlling the raw level autonomics. And with that, that brings about what we call the holistic nature of the GANA framework. In terms of compatibility with what we have seen so far in the industry, what we call the hybrid zone model, combining centralized zone and distributed zone, for those that are aware of that, you will see that the GANA itself as a model, if you look at the hybrid zone, the hybrid zone is an implementation of the GANA framework for the run. We've done a demo on 5G, advanced zone and distributed zone, and the policy control, as especially the C-zone as the knowledge plane, the GANA knowledge plane. We've done some implementation on that, and I'm going to briefly touch on that. Now let's zoom into the knowledge plane just to give a clear picture of how this concept looks like. The knowledge plane, as we are moving into what we are calling knowledge plane driven networking, is the brain for autonomic management and control. What we see is that the knowledge plane is supposed to be disaggregated, so specific to network segments. So we can talk about a knowledge plane for the run, for the XO transport, for core, and for a data center. And within the knowledge plane, we have different types of decision elements, like I've just shown in the previous slide. QS management, fault management, resilience and survivability, decision elements, as well as mobility decision elements. All these are defined by the standards, meaning what sort of DEs need to be implemented within a knowledge plane. Once the knowledge plane is instantiated, of course, the nature and the type of decision elements that need to be part of that knowledge plane is decided update implementation. Important is management and control systems, as well as the infrastructure to source telemetry, how telemetry can flow into a knowledge plane, and then the complex decision making algorithms. They implement what we call complex event processing, CEP. And with that, that means that a knowledge plane should be able, in reaction for strategies on how to remediate a problem in the network, can decide selectively either to reorchestrate via orchestrators or to interface with OSS and program the infrastructure or instantiate new services, new network slices via the different systems. So these are clients that must expose northbound interfaces to the knowledge plane. If you look at what 3GPP is doing, is also defining so-called analytics functions, and what we require for that integration is that knowledge planes can use the analytics services that 3GPP is defining, like NWDF and MDAS, to actually employ the services of the analytics functions. But at the same time, the knowledge plane can actually configure the analytics services that are needed per context and per dynamics of the network. So that's the knowledge plane. That's the brain of the network. Integration with ticketing systems, various type of data sources. This you can find in our deliverables. Coming to the very important subject. Today we are talking about autonomous networking, path to autonomous. The enabler for us at AFI is that we have, with respect to the relationship between autonomicity and autonomy, right? So the foundation is that a network, evolutionary wise, it needs to start as an autonomic network. What does that mean? That means that it has to be built with based on principles of hierarchical nested control loops, nesting because of what we talked about, time scaling. There's value in time scaling of control loops at specific abstraction levels from within the network element up into the realm of what we call the knowledge plane. So that is the property of autonomicity, is about control loops, interworking of control loops, hierarchical nature, nesting of control loops. Now let's come to, if we consider this as an infrastructure and we are talking about a path to autonomous networks, then we are looking at what is the property of autonomy of an autonomic network. It is about a degree and measure of operations tasks that can be performed by the autonomic network without direct human involvement in the decisions and actions. So we see the two properties, autonomic, autonomous. How are they related to each other? We have created that relationship, that autonomics, the control loops, the foundation, the science of control loops, they are the enablers for what we are talking about, the metric of degree of autonomy. Now, in terms of maximization of this, as we evolve networks into the future, the autonomic network can maximize the property of being autonomous by way of enrichment of the control loops or the autonomics of the network. And that is based on either the algorithms, algorithmic evolution, or because there's learning in the DEs, they are learning new situations, they improve, they are self-improving. So that maximizes the property of being autonomous with network. Now, another framework that is important we have defined inside the TS is what we call the framework for federation of autonomic management and control. Autonomic management and control, in a nutshell, means control loops in the management plane and control loops in the control plane and the interworking of those. Now, if you look at the federation, we're talking about domains, AMC domain A, AMC domain B. We have defined the levels at which to talk about federation by way of distributed control loops horizontally and also inter-KP in terms of negotiations on configurations. A type of one type of federation of KPs, what we call the knowledge planes, is what we call the horizontal federation, which is KP to KP. If you look at these knowledge planes, this is about also disaggregation. The likes of NGMN and a lot of groups are talking about disaggregation. And we believe, and NGMN has specified that knowledge planes needs to be disaggregated. We agree with NGMN. AFI agrees very much with NGMN and also with TM Forum on the fact that knowledge planes need to be disaggregated. So we have a knowledge plane for the access network, as you can see, that can be represented by CSON, especially for the multi-RAT radio access network. Transport network, we have a knowledge plane in the middle. Core network, we have a knowledge plane platform as well for the core network. Federation means that the knowledge planes have intelligence to look at the state of, let's say, the core network, how it has impact that the knowledge plane for the access network could self-adapt based on events and challenges that the core network is experiencing, such that slices can be reorchestrated and put on the different types of backup paths across the network end to end. So that's the concept of federation. There's a big picture of federation that you can see in our specifications. But moving forward, there's also what we call hierarchical or vertical federation of knowledge planes. That's also an option that is defined in our framework. An illustration, we have a TR that talks about instantiations. We have many instantiations we have done. So this is an example of instantiation of the GANA over the 3GPP, EPC core network and backhaul network as such. So you see CSON, DSON interworking on the part of the radio. On the part of the backhaul and core network, you have knowledge planes, and then the federation, the interworking, exchange of state, influence. For example, we've done a very good demo with Vodafone and Orange on how the knowledge planes can share incidents, security incidents, and the knowledge planes react by dynamically computing new security policies for self-defense and self-protection of the infrastructure they are responsible for. So there's work that we have done there. Framework for addressing stability. Type talked about stability of control loops. We have two principles we have prescribed in our specification. Is design for stability principles, runtime stability. We have done a lot of research funded in the US and in Europe on stability of control loops and the aspects of coordination. So we have a framework on that. How DEs, for example, auto-discover knowledge plane can coordinate or schedule plan of actions to coordinate various decision elements, routing, security, QS, mobility, and the like. So there's a framework that is defined in our work. Now, marketplace, how to innovate, how to support innovation of our AI algorithms for autonomics. We have created a framework, what we call the marketplace concept for AI algorithms for autonomics, tying together different stakeholders from data scientists, autonomic management and control domain experts, what we call domain experts, data management for training repositories, as well as suppliers of DEs, because we want DEs to be disaggregated from the hardware and software platforms, such that operators can select the best decision elements from the marketplace and change the autonomic network by way of changing DEs, by procuring DEs that have better algorithms, better decision making. All this is a kind of ecosystem we have defined. For the sake of time, you will see that in the slides and in a lot of our work, different white papers, different together with various SDOs. AFI, the GANA is adopted in many SDOs, in Broadband Forum, TM Forum, as well as NGMN in the end-to-end 5G architecture on autonomic networking, knowledge planes within the NGMN. They're based on the GANA framework, that specification for the 5G end-to-end architecture, and subgroup 13 and other subgroups within the ITU context. Looking at the interworking journey, as we discussed, started in 2009. We were an ISG, pre-standardization group, industry specification group. We moved to mainstream standardization. The deliverables you see here, they are a result of that work, of that journey from 2009, interworking with various SDOs, TM Forum, 3GPP, NGMN, as well as IEEE. There's new work on future networks in IEEE on systems optimization end-to-end with autonomics. That also has been is adopted on the basis of the GANA principles as we move into future networks. And certification frameworks for ANs. This is also something that we are doing. There's a presentation that is coming after this. I think there's some few minutes for some questions, but I'm wrapping up now. We have a 5G proof of concept for autonomic 5G networks and a consortium. And we have created an ecosystem by way of looking at what is the value of autonomics within the infrastructure, network infrastructure, and autonomics, GANA autonomics, within what we call the management and control room, which is outside of the infrastructure, and how to integrate with orchestrators. So GANA within knowledge planes, federation of knowledge planes, and integration with orchestrators, with SDN, with NFV, all that as an ecosystem, and consumers of network slicing. So it's very important, this ETSI proof of concept. We are delivering a lot of work in real implementations based on the GANA principles on fast control loops. How are they complementing the slow control loops? And that's very important for us, especially as we move into the future of knowledge plane driven networking. So we've done a lot of demos with vendors, especially on the advanced CSON for 5G. We have translated CSON into knowledge plane with Cellwise, which is a leader in the industry around the CSON, and other type of proof of concepts. We are planning for the upcoming proof of concepts. We have 3 proof of concepts that we demos as such that we are going to run. We have done also autonomic monitoring demo, how the network is self-monitoring, self-tuning, and is tuning the behavior of how monitoring data is transmitted and telemetry to different type of, let's say, components and knowledge planes of the network. End-to-end autonomic security management. We are starting standardization on that. We have done very good work on federation of security incidents and decisions across 2 operators, especially Vodafone and Orange, and also discussing with other operators that are within our scope. We have Verizon as well as Telecom Italia. So that's our consortium. With that, I would like to thank you, and these slides will be shared with all of you. Thank you so much for that. If there's any few questions, we can take those. If not, for the sake of time, please send us the questions. Matthew, myself, Tayyip, and our colleagues in AFI will be glad to provide some responses to that as we move gladly into what we call the era of knowledge plane driven networking, autonomous networks. Thank you.
That's fantastic. Thank you very much, guys. There are no questions that have come in on the platform, although I'm sure you will receive some. There'll be. I'm very pleased that you shared your contact details and that we have a platform which will enable contact as well for people who do have follow-ups with you. But thank you very much. Yes. Yes, thank you for sharing that email, and thanks again for presenting. And enjoy the rest of the show.